this is something that I like to simulate. But I'm having trouble at two parts. For my basically what we have here is we have propane, butane, and water. And so this number 3 is propane, number 1 is butane. Both contains water. And so I am using like cooling them down so that we can separate we can separate water from the water from this propane and butane mixture. And so this one right here, mostly in aqueous, the water is mostly in aqueous phase.
Yeah.
Right, so most of the water is in aqueous phase, but for butane, it's not. Everything is in vapor phase. So I use the cooler to lower the temperature, and trying to separate water into aqueous phase before combining them into like a separator here.
Okay.
And so 5 is supposed to be like water, or liquid, and then 4 is propane and butane mixture, and then increasing the pressure right here. So the first problem is
you cannot run this.
I'm not. The first problem that I face is I'm not sure how to. I want to control this cooler here so that they. How do I say that? So that there are more temperature difference if there are. How do I say? I want to control like the water phases here. So if there's not enough water, or if there's not enough, or if there's like hydrocarbon in aqueous phase, this needs to be lowered down, or so that's the first problem that I face. And then the second is how do I put in composition in this table right here? Can I send this to you?
Yeah. You can just put it here, so then and put it on this chat, right? So I guess that you want to run this in dynamic, yeah.
Yeah.
And you know that you cannot run this in dynamic the way that it is now. Are you aware of that? Are you aware of that or no?
No.
Okay. Have you tried so?
I have not.
Okay. And then because this is not enough yet, because you need to put valves. Remember that you need to put valves in all streams.
Yeah, but I'm using exchanger here as well.
That exchanger is fine, but then the other 3 streams you have to put the valves.
Okay. Alright, so hold on, I'm sending this to you. Okay, I don't remember where I saved it.
Desktop. Oh, what you is a newer version. So how do I open this? You have to tell me that again.
It's in XML. Can you try first?
Okay, it's XML already. Yeah, and then I just need to open, or how do I do this? Open, yeah.
Yeah.
Okay. Okay. Yes. And then it should be somewhere in download. No. Where? 1 minute, yeah. So it's all. If I download this, download complete. But then complete download. Oh, it's there. Okay. So all files. Can you I don't know. Let me check.
Can you share screen?
Share screen. This one, yeah.
Okay. Yes.
So this is stream one. Okay. So I'll upload it anyhow. So number one. So this is a cooler, right? So what does a cooler do?
Reduce temperature.
Reduce temperature. So why are you having a close to 1 bar? 1 bar. 1 bar. Oh, okay.
It's 100 kPa. Yours is in kg cm squared.
Yeah, somehow. A minute, yeah. So, okay. Looks okay now. Okay, so it's 1 bar. Okay. Let's make it like some more bars. Huh?
All right.
And then we have nothing in the vapor. If I put it there. You want to say it again? What do you want? You want to remove the
water from this butane.
Okay.
It's like a feed preparation.
Okay. Okay. Yeah, you put you put the pressure too low because it won't be good for dynamic.
Alright.
So I just put this 5 or 4. At least we need to have like a some pressure drop around the system, because if put it this already 1 and then there's a 0.8, right? You saw it, and then this has to be then at least lower than 0.8. And then if this is then at the higher pressure, and then there won't be any flow coming from this side.
Okay.
Yeah. So so we need to increase this to, I don't know, maybe 4, maybe things like that. So in this case it has already like this liquid, but it's two phase of liquid. Liquid phase for the butane, and then the aqueous phase. In this case, you know that you can also use, if you want to, I'm not really sure, do you want to separate the water from the liquid hydrocarbon, or just combine them as liquid?
I want to separate water and then converting hydrocarbon to liquid hydrocarbon.
Okay, so it means you want to have like a 3-phase separator then.
Okay.
Right, so 3-phase separator, so you don't need this. So what you need is then the 3-phase separator, this guy. And then this is going to be at 1, and this is going to be another. This is going to be coming from the vapor. This is going to be your liquid, and then you have the another heavy liquid, what they call heavy liquid, but in our case it's going to be water. Yeah. So so in this particular case, what we have, you can see this. So I think it's for the sake of clarity. 1C is then your feed, right? Feed coming in, and then 3 is then another feed, and then 5 is then the liquid hydrocarbon. So this is then the lighter version of the, I don't know, can you see this? Can you see this weir?
Yes.
Yeah, so the liquid coming here and gas is also coming here, and then the heavy liquid will then go to this boot, and while the lighter liquid will then flowing on top of this. So it will then flow over the weir, so that this part is then going to be this is going to be the lighter liquid, which is then sent to this stream. So stream number 5 is then the lighter liquid. In this case, going to be hydrocarbon. Stream number 4 is gas. Stream number 6 is then the heavier liquid, which is in this case the water. So we can see in the composition. So 6 is then the heavier liquid, which is then the water, and then number 5 is then the lighter liquid, which is then mostly the propane and butane.
Alright.
Yeah. So so in this case, you have them all separated already. But then this controller, um, you want to reduce the temperature, or you want to increase the temperature. What do you want basically? Because if it's cooler, that means you want to reduce it.
At first, I want to reduce the temperature as to separate the water from the hydrocarbon.
Okay, so in this, okay, we will just then cool the temperature. So that means if you want to cool temperature, so that is then this temperature, the 4 degrees C, this temperature is going to be our process variable. Yeah. So the PV is then our process variable. This one is not correct to do so, because what the cooler does is then to reduce the temperature. So what we are measuring practically is then the temperature. So in this particular case, we have to change this from this to temperature. Okay, so this temperature, and then
Doctor, is there a way for us to control? I understand that we would have to use cascade control, but
you don't need to use cascade control.
No, I mean, is there a way that we can control the amount of water in vapor phase for the stream in 1C?
The amount of water in the vapor.
Yeah, the amount of water in vapor.
Because in the end, if you look at this, your water, yeah, we have some amount of water in the vapor. In this case, we have to go back to thermodynamic. So okay, so I will show you. Yeah, I think we can see it here. 1 minute. Yeah. So we need to find, what we need to do is then you need to find the correct operating conditions, pressure, temperature, in such a way that water condenses while the gas, these light hydrocarbons, are not condensed. That's the correct way to do. I don't see it. Stream analysis. Okay. This one, boiling point curve. I think boiling point curve. Just use this. Let's see. Boiling point curve. Okay. What happened? Do I see anything? No. I see nothing. Generate. This guy. So let's see. Less than 3 significant components. Okay, I don't really care. Let's just look at volume. At least 3 components. We have many components here. I don't know how to use this. We have also, what else do we have here? We have also I think the envelope. Let's see what this envelope does. There's nothing. Okay, it does something. Bubble point, yeah. Bubble points or dew point should be okay, because we are now moving from the gas, right? So you're saying I want to have the dew point. So yeah, nonetheless, this is then this is then the curve. This is from the table, so this is then the curve. So you can see Stream number one is 4 degrees C, about 4 bar. So 4 bar is somewhere here, and then you have 4 degrees C, right? So 4 bar, 4 degrees C is somewhere there. So this part is then the vapor liquid equilibrium, the dew point line, and then this part is then the liquid line, liquid phase. Sorry, this one is liquid phase, and this part is then the gas phase. So if we see this at 4 bar, at 4 bar, yeah, 4 degrees C, it's all in liquid. Yeah, as we can see it here, it's all in liquid. What you like to have is some still gas, but then some in liquid here. That's what you would like to have here.
I'm not sure. I'm just wondering if we can control the cooler using water composition, as in like an analyzer.
No, analyzer is to analyze, and then you are not using analyzer to reduce the temperature, right?
So
it won't happen. Yeah, cascade control. It's going to take long, yeah, because in practical, yeah, we do analyze it, but then because what you want to analyze is the amount of water in the liquids, right? So the amount of water in the liquid. One C. This is okay. Because if you see this, because this stream 1C, it is in the liquid phase. If you see it here, you have 4 bars, and then the 4 degrees C. That's in the liquid phase, and then in the liquid phase we have aqueous and then liquid. So at this temperature, there is no way that we can have water in the liquid while the other in the gas. So what we need to do is then, if you would like to have it, that means we have to start from the gaseous phase, and then we'll then try to reduce the temperature in such a way that it will then touch this line. Can you follow this, my mouse? Yeah. So that we reduce the temperature, and then we see how much is then water is being produced. You could do so, but then we need to tweak this a little bit. Because we need to find out where that condition is. Yeah.
Okay.
So for example, if we can see it here. So it's let's start by 60 degrees C. Yeah. So it's 60 degrees C. So it's vapor, because 60 degrees C is somewhere here. Yeah. So it's vapor, and then if you do, for example, say we would like to see what the temperature here at 4 bars. So what we need to do is then we can just delete this temperature, and then put vapor equals to 1. In this case, going to be saturated, so that this is then the 50 degrees C, somewhere here, 50 degrees C. So if the vapor is 1, it's 50 degrees C. So if the vapor is, like, for example, 0.5, yeah, that means 0.5 vapor, 0.5 liquid. So we can see the temperature is 41, so somewhere here. The composition is that we have this amount of water in the liquid, and then there's nothing else. So let me check, where's that thingy. Where's that? Okay. So if I put, like, you can see it here. You can see it here. Because you don't have enough. Let's see here. So 0.1. If you can because if we change the vapor temperature, the vapor fractions, the temperature will change, because it's a two-phase. It's more than one. It's more than a single phase. If I reduce the vapor, that means it goes to the lower temperature. but then you have to check on the liquid phase there, the compositions of water and liquid phase will change or not. So it doesn't change, so it's a 0.5. It doesn't change as well. So 0.8, it doesn't change as well. So 1 is also, it doesn't change. So from this exercise you can see that there is no way that you are now trying to control whatever it is. Yeah, it's already like in a very 0.000, so it's it's going to be very difficult as well to control. So in that sense, maybe you have a noble intention, but that noble intention is not enough to do something useful. Let's just make things simple. Let's make things simple. So here you can try. You can use just like try to control temperature in such a way that it's coming like 60 degrees C, and then you can reduce. You can use this cooler to reduce the temperature to yeah, whatever temperature that you would like to have. Okay, so I think that should solve. Well, it's not solve, it's just to give you an idea on what we can do and what we should do prior doing anything that we would like to do. So we need to make some preparation, yeah, which I just showed you whether we can do it or not. So that's for the issue number 1. And in issue number 2, you would like to add something here, yeah? Yeah, just double click.
Water concentration.
Just double click, and then add variable, and then you want to see water concentration. Water concentration. Mana dia? Concentration. Check for water only phase. Yeah, I don't know. Just take that. I don't know what this is. Where is that here? Concentration. Oh, master component mass flow. Where is that thingy? Component mass flow. Okay. Concentration, yeah, mass fraction. Water. So that one. Why they call it master? This one I don't know. Is there any slave? I don't know. Slave. No slave. Master. I don't know why they call it master. So done. So now you have checked for only water phase. It's yes or no. Very strange. I don't know what that is. Nonetheless, we have like 0.0095 of water in the gaseous stream. So I think this one I can just remove here. There we go.
Alright.
I think we can. Am I reducing this? No, yeah. I'm not reducing this. Format. Significant again. Because I want to make this smaller. I don't know how to do this.
I've been figuring that out too.
Did you find the solution? No.
No.
Okay. Fine. Yeah, if you want to add or remove variable, just double click on this and then you can have this page.
Alright, okay.
Okay. In this case, control valve is then is it positive or negative? I don't remember. Positive. So how much was that? 9. So we make it like 9. So 0.1, 0.2. E um, to E6 and then PV is I don't know, minimum is 0, maximum is like 60. Auto 5, I don't know. This is then half to make things. And then you say if this temperature increases, we increase the. If temperature increases, that means we need to remove the temperature. We need to remove the heat. Yeah, removing the heat. That means we want to go to removing the heat means we need to increase this guy, increase the value because it's positive. So temperature increase, we increase the duty. Temperature drops, we drops the duty. So it's a direct. Yeah. Okay. So
Okay.
and then the pressure. Yeah, in this case we need to put the valve.
Okay.
So yeah. So in this case we can then yeah, very low pressure, make it 5. And then this one is then maybe half a bar of pressure difference. Yeah, and then we add another valve over here, and then another valve over there, because we can also yeah, instead of this we can have this dynamic help, yeah, dynamic assistance, so it can help us. So disable pressure specifications like that. So we can go. So it says here stream 7, stream 2. We have to disable the pressure specifications. So in this case, we can do yeah, make change on this. This one we remove the pressure spec. But we will do that later, yeah, because we're not complete. We're not complete with the this one append a new valves and stream. See, it asks us to add valves and stream to stream number 5 and stream number 6, which we were about to do.
Alright.
Okay, so it doesn't ask us to put valves over here, so that means it's okay. Yeah, because this is, in a way, this is like a pressure changer, and this one is also a pressure changer. So they don't ask us to put valves on these two streams. So only for this stream 5 and 6, so that's also a good and then enable pressure flow equations, not pressure drop. We will do that later. And then the volume is not known, so this volume is then not known yet. So you can see pressure flow spec is the E100, yeah, and then the size is then the volume. See, this volume is not known yet. See, it's still light blue. Light blue means it's just like a suggested volume. So it's if it's input, it has to be like a dark blue like that. Okay, so first thing first, put the valves. In this case, we can have like maybe 2 bar, and then in this case we can have it's also like 2 bar, for example. And okay, we need to size this valve. Yeah, size the valve, dynamic or rating, sorry, rating, and then yeah, we can make it a size valve, for example, and then it becomes dark blue. It's very easy. Yeah, otherwise we have to size this manually. That also can be done, yeah, if you want to, but to have a quick feeling on this, it's just like that. And then the vessel, go to rating, and then see there's nothing. So we can do quick size if you want to. Quick size, so we have diameter 0.45, so let's make it half a meter, and then length is then 1.5 meters. So let's make it yeah. It has a boot, so it doesn't have, I mean, in this case we don't see there's no wear. If you can include the wear if you want, but see, and then you need to do the positions of the wear, physical height. So yeah, it's too complicated, and then we don't want to do that. So it's just like there's no wear. Yeah, so I mean this line is not there. What we have is only like the boots. So all heavy liquids will then go to this, while the lighter liquid will then just flowing around over there, which is then taken away. And then the the heat exchanger, it needs to have like a pressure spec. We go to dynamic, and then in this case we typically use this overall K. Yeah, we can calculate K. K is calculated, I think. Yeah, calculated already based on this volume. So we have to tick on this. Okay. And compressor, I haven't touched this. So what have you done? This one, don't know parameters. No. There's no curve. You can add the curve, but I think if you can click enable curve, no. Let's see how we do this here, because I haven't done this curve in HYSYS. It's much simpler to do this in symmetry, but nonetheless, what we could do is that we could just do this. For example, the 1 kilowatt. We got 1%. I don't know. Oh, you have the pressure ratio. Oh, okay.
Yeah.
I have to remove this number. Pressure ratio. Efficiency is like I don't know, 0.7. Oh, 70. Must have 70. And then this is then the kilocalorie per hour. In this case, we need to add the curve. Let's see here. Does it say something that we need to add the curve? We could add the curve, which I would normally do, but let's see what this dynamic guy say.
Why do we need to add a curve? Is it like a sizing?
Yeah, that's the sizing of the compressor. So
okay.
I'll just show you. See this compressor curve. Yeah, let's just click this. Hey, where is that? See, so we have this efficiency. So this circle is an efficiency. Yeah, so it's the high sorry, the speed 100%. This is your design speed 100%. This is then the speed 110, 120%, and this is then the surge limit, and then because it's this centrifugal curve pump or compressor, it works based on this head and flow correlation. So if we have like a 60 flow running at 80% of the speed, this is then going to be the head delivered by the compressor. So if we increase the flow, we are still running at the same speed. Yeah, if we increase the flow, I mean it will go through these lines, and then the head will then be reduced. Yeah, So we can increase the RPM, so from 80% to 90% to get some boost in the head, in the pressure, for that same. So in this case, we need to design the compressor curve, but it doesn't say that we have to do it now here. So that's a bit strange, but nonetheless, I don't know. Disable flow stream pressure specifications, so we can see it here. Pressure spec, yeah. So stream 7 and stream 2. In this case, stream 7, because we specify the pressure over here, so it's better that we specify the delta P instead of the pressure. So half
0.5 bar.
This is then half a bar. Yeah, and then the what else? Go to dynamic. Nothing. And then stream number 2, which says we did not specify anything. Oh, set pressure. Sorry, we have to set the pressure. So because we are setting the pressure here, right? So this dynamic, it says set pressure there. So we have to set pressure over here as well. So what to how much we want to compress it? Say for example 10 bar. 10 bar. Right? How much is that? This is pressure is 3 bar and we're compressing it to 10 bar. Oh, okay. Hey, we have the 1.15. Yeah, so that's the that thing, pressure ratio thing.
What if we just compress it so that it can be converged to stream number 8?
Stream number 8.
Because they are both hydrocarbons.
But this is gas, this is liquid.
Yeah, but we compress it to liquid. Is that possible?
You compress this into liquid. It's that liquid change is not going to happen in the compressor because it will then break your compressor. So you either compress this and then you cool it down to get the liquid phase, and then the gaseous part you compress it again and then cool it down again, and then that's how we get the liquid. Yeah, we can do this later on. Yeah, but it says the let's do things simpler for the sake of simplicity. Disable post spec. This okay. This one, stream number 1 and stream number 3. So stream number 1, it has to be flow spec, pressure spec only. This stream number 3 is also like a pressure spec only. Okay. And then now we can do show table here, and then show table there. So I have an overview of what is happening. Show table there. Okay. Configuration, no. Any configurations, no. Yeah, nothing. Nice. Okay. Nonetheless. Now in this case, dynamic says nothing, no problem. So we can just run this. Dynamic mode, yes. So it's now in the dynamic mode, and then we can click on integrator, and then we can either real time or do accelerations. Yeah, we did accelerations like 10 times to make it not so slow, but also not very fast. So we can click start. Failed to converge. I don't know what the problem is. Hey, this one is not. What is happening now? This one is not really doing something. See, you are now varying the compressor speed, so I missed this part. But you don't put any speed, right?
I'm
it's just there, but it's not. It has to be an input. So this one, the one that you want to manipulate, it has to be an independent variable. It has to be an input. While the speed in this case is not an input. This is then the calculation. So in this part, we have to then play around with the duty, because duty is then the input. So because duty is the input, so that means we have to energy. What's then the energy? Stream K100 or Q100. Q100. Control valve.
Okay.
Yeah. So it is now. Why is that so? Very strange.
Negative.
That's very strange. Maybe 5,000. I don't know. Yeah. 5,000, and then the PV automatic set point. Oh, sorry. The process variable is what is then the process variable? So you want to have stream number 2, and then pressure. Pressure is this guy.
Okay.
Yeah, I don't know what that the other pressure was. I think in that sense we have to find in help and to see what that really is. So automatic, and then the PV is pressure. Yeah. Okay. Minimum is this, maximum make it 10. So set point is, yeah, if you want to make it this, or maybe make it 5. I think that's it, right? So dynamic assistance, nothing. Integrator set, and then see what happens. Now it's doing something at least. See, the pressure here is suitable. See, the pressure here is very low. It's 4 bar over here, but we have the stream number 2 is a 4.5 bar. So you can see that the flow rate, instead of going that direction, it goes through the compressor. So it already breaks the compressor, it gets to the vessel, and then it gets to the it goes back to the stream number 1. Yeah, so in this case, why? Because you have a low pressure here, 4 bar, and this is 4.5 bar.
Oh, okay.
So this vessel, it has 4 bar, 4.002. Right, so this 2 bar, so there is a flow, positive flow. It's a 2 bar, there is also positive flow. See, all positive flow. This is 4 bar, 4.5. This is 4 bar, so there is a negative flow flowing back. See, and then because there's also a 4 bar lower than at least this 4.002, so there is a negative flow through here. So what you could do is then you could either change the set point over here to make it like a 3 bars, and then it doesn't work. What am I doing? Because we need to check on the control valve.
it is the compressor. It's supposed to increase the pressure.
Yeah, something is wrong here. So it's a 4, and then it's you cannot make it to 3. So it has to be like a like that 4.5, like what we just had. Right. So so in this particular case, what we should do is then increase this pressure to 5 maybe. So
Okay.
There's no flow here. That means
Because
all the gas is then being compressed in this vessel, and then it goes to this liquid. So we can look into this vessel composition. So this whole gas is then going to stream number 5 and 6, 5 and then 6. They all have the same number. That means the liquid and the vapor, liquid and then the heavier liquid, which is then the water, they are like mixing up, right? So you can see all the concentrations are all the same, so they're mixing up. The volume is 0%, so that means simply they're mixing up, because there's no volume. Let's check here. Strip chart, we have a strip chart. No. What we could do is then now we have to make a level control here, and then make a level control on the boot to make sure that we have the sufficient level to make sure that there is some separation happening.
Okay.
Stop. Well, it's 10:28, so I will just let you do this. Aisha, I will save this.
Yeah. Can you share this document in the group?
Do you want to proceed? Then I need to save as IC simulation, and then I can just send it to you, or I need to send the XML.
I think it's okay.
For you it's okay because you have a newer version,
Yeah.
I send this both to you. This then the default steady state file saved by HYSYS. Try to control the flow, the level in both liquid and then water.
Okay.
And try to run it and see if it runs according to your expectation.
Okay.
Has it been shared? No, yeah. Okay. Okay. Yeah. So 1 minute left. Do you have any other question?
No, I will try to do this first, and then I'll let you know if I have questions.
Yes. Please do so. Yeah, please do so. Yeah. Okay. So let me know. Just keep on doing it. Yeah. So I think you're getting somewhere. And then I'll see you next week. Okay.
All right. Thank you,
Thank you.
doctor.
Thank you. Bye bye.